Hi girl, here's me again. This time I would like to talk to you about factors that affect photosynthesis. That's a very common question that comes up in tests much or more often than actually having to explain the process. So here in this diagram you see the effect of temperature, and the reason temperature affects photosynthesis is because photosynthesis is an enzyme-driven process. And here on the left, where the temperature is low, enzymes have very little kinetic energy, as have the reactants, and therefore the reaction rate is very slow because the particles, so the enzymes and the reactants, don't collide at a sufficient rate. On the other hand, when the temperatures become too high, enzymes get damaged and denature, and then also obviously photosynthesis comes to an halt. So there is a range where it's just warm enough as before the enzymes start to denature, where the reaction rate is at its peak, and we call that the optimum temperature. Photosynthesis is also affected by the intensity of light. So to a certain point, you can say the more intense the light, the higher the reaction rate, because obviously more intense light means that there is more light reaction happening, more ATP is made, more NADPH is made, and therefore more glucose can be created. However, as you can see in that graph, that only is true until a certain limit is reached. So here the curve levels out. So what's happening here is that the enzymes and also the light pigments are working at full capacity. So the enzymes are working at full speed and they're all fully saturated, and there aren't any more enzymes. And also the pigments are absorbing as much light as they can. So even though you might increase the light intensity further, the reaction rate is now limited by the amount of light pigments embedded in the thylakoid membranes and by the number of enzymes available to catalyze these reactions. The same is true, by the way, for it's not only the light intensity that is all affecting photosynthesis, it's also the wavelength. Wavelengths obviously need to be correct and needs to be in a range that can be absorbed by the pigments. So if you don't give the plant light in the proper wavelength, then it can't photosynthesize either. The next factor that is limiting photosynthesis is the carbon oxide concentration in the air. So how much carbon oxide is available for photosynthesis, because carbon dioxide is one of the reactants that is needed to make a glucose molecule. And again, you see that with increasing carbon oxide concentration, the reaction rate is going up to a certain level where then the curve is leveling out. And again, at this stage, the reaction becomes limited by other factors. So there could, for example, be not enough light, or maybe all the enzymes, not enough enzymes to increase the reaction further. So in summary, the limiting factors in photosynthesis are light intensity, the wavelength of the light, the temperature, and the carbon dioxide concentration. So as you can see here in this diagram, this is the rate of photosynthesis going up with light intensity. And you see here, this is the curve for 20 degrees Celsius, and this is the curve for 30 degrees Celsius. And you can see that at 30 degrees Celsius, the rate of synthesis is higher than it is at 20. Both curves, however, are leveling out because at this stage, other factors become limiting. So here is a summary of photosynthesis. This is the essence of what you need to know. And you see here at the bottom, just like for respiration, you will have to discuss how the structure of the chloroplast is adapted for efficient photosynthesis. And I'm not going to read this out. You can read through this, and it's very similar to mitochondria and respiration. Here is a comparison between photosynthesis and cellular respiration. That is also a question that often comes up in exams. So have a read through that. And lastly, some work to do.